All right, welcome to Multifamily Air Sealing and Compartmentalization. This course is approved for 1 hour in continuing ed, and unique to our course is this one is also approved for lead AP Homes specific, as well as AIA-HSW, AIBD, NARA Green, Certified Green Professional, and may be applicable to local state-based design or contractor license. My name is Brett Little, and I'll be your moderator today. I'm the executive director here at the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Real quick shout out to our members, sponsors, board of directors, volunteer. We wouldn't be able to do these sessions without you. And for many of you, support our work, help keep these events going, become a member, and learn more about some of the benefits of that today. All right, so with that, I'm really excited to have Steve here as our first presenter of the year for this series. Steve is coming from the Stephen Winter Associates. And I don't believe, Steve, you're not the Stephen Winter, right?
No, I get asked that a bunch, but definitely not.
Yeah. All right. Good. Very close. Just wanted to clear that one up. So, real quick here, Steve with Stephen Winter Associates is just loading your bio here real quick, Steve. Sorry about that. Senior Sustainability Consultant. He is registered architect with experience in architectural design, construction, weatherization in residential buildings. He currently specializes in LEED for Homes and Energy Star certifications, as well as residential energy analysis. Since joining Stephen Winter Associates, he supported building science efforts, including the U.S. Department of Energy's Building America Research Program, and he trains numerous groups of contractors, architects, developers, mechanical system designers, in best practices for high-performance housing. So with that, Steve, thanks for joining us, and I will hand it off to you for the hour.
Okay, thanks, Brett. Let's get past all this boring stuff, copyright, course description. Everyone should know what we're talking about, but basically we're talking about why we need to worry about this multifamily air sealing stuff, how to do it, the big picture, beginning to end. This is going to be specifically focused on multifamily buildings, and that's my specific forte. That's mostly what I do, from upstate New York through Connecticut, New York City, New Jersey. That's my wheelhouse, but we do stuff all the way from Maine down to Virginia. But basically, this is multifamily buildings. Mostly they're going to be affordable, and then we'll talk about some examples later. And the most important thing here, I'm going to point the presentation toward architects or anybody who is responsible for getting these air sealing details into the design and making sure that the details actually get implemented and you meet your goals. Learning objectives, let's skip over those. There's more interesting things to talk about. Okay, so here's our agenda. We're going to take an intermediate question and answer session. So like Brett said, if you want to save your questions in the first half of the presentation for then, that'd be great. And then we'll have another one at the end. Okay, so why should we air seal? I find it's always helpful to go back to basics when you're talking about a general concept like this. So number one, top of our list at least, is to save energy. Also, all these other things, overcome stack effect, stop moisture drive, which is becoming more and more of an issue, control smells and sounds, achieve fire stopping, which everybody has to do, occupant comfort, pest mitigation, and last but not least, program compliance. So luckily, more and more buildings are actually getting certified under some sort of green or energy program, which is great in general, also great for us who do this as a living. It's becoming more common. We're busy, so it's really great. So first reason to reduce air leakage is to save energy. No-brainer. Air leakage equals energy loss, period. They figured this one out a long time ago, and it still applies. So the more you can reduce air leakage, the more you can reduce energy loss. Stack effect. This diagram is meant to be an animation, so there's lots of arrows and things going on. Basically, when you have a building that has any sort of decent height to it, in the New York area, we have a lot of multifamily residential buildings that are, well above 6, 8, 10, 12, 20 stories. The taller the building gets, the more stack effect you get, which is basically heat rises, it's going to suck energy out of the building faster with more airflow from the stack effect. So these pink boxes indicate individual compartments of each unit in a multifamily building. We don't want the building to behave as one big box. We want it to behave as a bunch of little airtight boxes so that you don't get this major stack effect. These big arrows indicate that major stack effect. What we try to do with the little arrows here is introduce, let's see if I try to get an arrow for you guys. There you go. Does that work, Brett? You see that?
Yeah, it's working.
Cool. Okay. So these little arrows are meant to indicate a dedicated outdoor air source for each apartment unit. So that's the air coming in the building. And then they connect to these central risers that are connected to these central exhaust fans. So instead of these big arrows letting air circulate throughout the building willy-nilly, which is not what we want, instead we want to compartmentalize, make each apartment a little bubble, give it the right amount of ventilation, and send it out like it's meant to be sent. Okay, here's another one, another diagram. This is kind of a mid-level building. This is a picture Dave Keefe took up in Vermont, which is a really great example of stack effect working in real life. So at this yellow line here in the middle, you have the neutral pressure plane. So that means that there's really no air movement happening at this level because the pressure above and below, inside and outside, they're equal. So in order for to have air movement, you've got to have a driving force. At this point, we don't have one. However, at the top of the building, up here, you can see the plastic billowing. That's due to stack effect. And the other half of that equation is down here at the bottom, your red arrows. See how the plastic is being sucked in. That's basically, these red arrows and green arrows put together is, walking down the street, you can see this example of how stack effect works in a building. So multiply that times many, many more stories, and that suck and push that you're seeing in this picture gets amplified. Another reason, stop moisture drive. This is an image from South Base that's been around for quite a while, but again, it still applies. On the left, we're seeing a 4x8 sheet of gypsum board with certain interior temperature and relative humidity. Through diffusion, which is moisture moving through a solid material, you're going to get a third of a quart of water per heating season moving through that sheet of drywall. Now, if you introduced a 1-inch square hole right here on the right-hand side, same sheet of drywall, same conditions, same heating season, but with one difference. You had a 1-inch hole, now you're looking at 30 quarts of water being moved through this surface instead of just a third of a quart of water. So that's how important air movement is for moisture drive. Sound and smell. This is just a picture of, this actually doesn't happen a whole lot. These are dense packed cellulose demising walls as well as exterior walls. Everyone's been there, whether it's an apartment building or a hotel. It's super annoying to hear the people next to you, above you, below you. Same thing for smelling what they're cooking. So basically, just like with energy and moisture, air leakage also contributes to sound and smell transfer. So if you can knock down the holes, you're going to be able to knock down the sounds and smells. Fire stopping. This one, hopefully everyone should be pretty familiar with. What we're seeing here on the left-hand side is putty packs, which is required sometimes in demising walls, depending on your assemblies. On the right, you're seeing fire foam. Every jurisdiction is going to be different. Some people don't allow fire foam, for example, but long story short, fire smoke is going to move faster through a hole than it is through a solid surface. Improving occupant comfort. This is a PTAC. This one we have found is a common problem in our affordable multifamily buildings, especially in New York, where PTACs are a very simple solution to heating, cooling, and ventilation. The problem is that they are super hard to get airtight. So what we find ourselves doing is working harder than we need to in other areas of the envelope in order to make up for the air leakage that comes through these PTAC units. So to improve occupant comfort, basically, you want to minimize that cool draft that you get in the middle of February that is going to make your apartment feel colder than it actually is. Pest mitigation. Ants are definitely not the worst thing that I've seen creeping through holes in drywall penetrations under sinks. For some of your green programs like Enterprise Green Communities, for example, you're required as part of your integrated pest management program to seal up all these penetrations to make sure that you don't have all kinds of nasty things crawling into your apartment from somebody else's apartment. Okay, then last but not least, the reason air seal will be program compliance, lead NC. In orange, you can see what our options are for controlling environmental tobacco smoke, unless you have a no smoking building, of course. This is 0.23 TFM 50 per square foot of enclosure area. This is the first time you're going to see this word in this presentation, compartmentalization. That is basically what I mentioned earlier, making each apartment its own little bubble within the overall building envelope, the big bubble of the whole building. Standard hasn't changed recently. It's just phrased slightly differently. LEED for homes. There wasn't actually a limit in the performance path for the current / older version of LEED for homes. This would be the pre-version 4 version of LEED for homes. You can see down here below what the prerequisites are for the prescriptive path, and then the additional points that you can get. These are the targets for supplemental points. We don't see, oh man, we'll get downwards of 3 ACH 50 sometimes, but the teams typically have to try pretty hard to get there. LEED for Homes V4 requires Energy Star, at least on the low-rise side, and there is actually no prescriptive path for Energy Star now. So really, it's just based on whatever air leakage has an effect on your HERS index, basically. So if you want to switch to the mid-rise side for LEED for homes, the prerequisite in 2010 is this 0.30 CFM 50 per square foot. And the enclosure area, in case anyone is wondering, is just basically the apartment itself, basically the line you draw between the apartment and anything around it. So that includes exterior walls and ceilings and floors, demising walls, corridor walls, and floors and ceilings. Let's see. Nobody really cares about these points. You can feel free to email me if you have questions about this stuff. But long story short, the requirements are getting tighter to get points for LEED for homes mid-rise. Energy Star compliance. Basically, it affects energy models. So depending on what your local programs require, like for example, for state incentives in New Jersey, there is no infiltration requirement right now, whereas in Connecticut, it's pretty tight. I don't know how it is in the rest of the country, but it's going to vary state by state. But as far as the national program goes for Energy Star, your air leakage is going to affect your HERS index. Energy Star multifamily high-rise, again, this is a compartmentalization standard, 0.30 CFM 50 per square foot enclosure. If you try, it's actually not that hard to hit, but you're definitely not going to hit it if you don't pay attention. And you, meaning designers out there and the people who are in the field who are working with the workers who are actually doing the work. Passive house, this is awesome. We're seeing a lot of passive house work. Basically, they're just getting lows down super, super, super low. 0.6 ACH 50 is super, super, super tight. You're really going to have to bring your A game if you're going to get to that level. That's the international passive house. U.S. is 0.05 CFM 50 per square foot enclosure. And for multifamily buildings, you still have to hit that 0.30 CFM per square foot for each apartment. Code compliance. Climate zones 1 through 2, 5 ACH 50. Unfortunately, we don't have any project in those areas. For those of you who do, 5 ACH 50, again, it's not too hard unless you're really not trying. Up here in the Northeast, we have to hit 3 ACH 50 and we're seeing a bit of a learning curve with our builders who haven't been pushed previous to this code. They are having a little bit of a hard time hitting that 3ECH50. On the commercial side of things, we still have the rated assembly option, which in our opinion is not worth a whole lot unless a third party is getting their eyes on these assemblies. You can test the whole building, 0.40 CFM 75 per square foot. We don't see that happen very often. Okay, so how and where does air leakage occur? All right, this football is a kind of holdover from the last time I gave this presentation in Boston, and it just happened to be right after Deflategate. So you can ignore the image right now. Actually, the Boston crowd wasn't too. They didn't think it was very funny. But anyway, there's an animation that went along with this. So sorry, you guys in the Boston area. So basically, you need two things for air leakage. Still not funny, Mark Norton says. Thanks, Mark. You need an opening and you need a driving force. Real simple. That's all you need. So as far as openings go, cracks, small holes, large holes, or even materials that are permeable, like your fiberglass pads, sorry, but they really don't do a whole lot for you when it comes to stopping air movement. Driving force can be wind. Everybody's got that. Stack spec, we talked about that before. Or mechanicals. Misbalanced HVAC system can cause air leakage. Where does air leakage occur? Short answer is everywhere. The slightly longer answer is that any place you have a connection between assembly, ceiling to wall, wall to floor, wall to slab, even penetrations, connections that way. Any place you've got even a hole in your drywall, number 14 here is supposed to highlight electrical box. Anytime you've got any sort of inconsistency in your envelope, you're going to have air leakage. Now, if you're in the middle of a big sheet of drywall with no holes and whatnot, you're really not going to have any air leakage there. Now, you will have air leakage, though, where that drywall connects to the floor because it's a change in material. Okay, ambient versus adiabatic. Adiabatic, in case you haven't heard that term before, equals no temperature difference across assembly. So when I'm working with architects and they say, well, does this wall have to be insulated or does that wall have to be insulated? If there's no temperature difference across assembly, that means there's no heat transfer across assembly, and we really don't care about it as far as heat transfer goes. When we talk about compartmentalization, we definitely care about it as far as leakage goes. So to take an imaginary unit that has the same surface area and volume, this one's detached, this one's attached. The detached unit has 100% ambient exposure, whereas only 16% of that exact same size unit is exposed to ambient conditions. So this affects energy consumption in a big way, but it should also just, we won't get into the weeds about that, but basically just be cognizant of how your unit is exposed. How can we control leakage and provide sufficient air sealing? Rule number one, very simple, and it's just geometry. Again, this right here, it says equal volume and floor area. So this imaginary unit that I've created, same volume, same floor area. This one's square, and the one down below is rectangular. There's 9% more enclosure area to that unit below, all else being the same. So it depends on what your testing metric is. So up here, if you're doing an ACH metric, you care about volume. So basically there's no difference between these two units as far as your testing targets go. Now, if you're testing according to CFM 50 per square foot, your enclosure area, you have to work 9% harder to pass in this rectangular shaped one on the bottom. Simplify your enclosure area. I know it's boring, and for you designers out there, I know boxes aren't easy to make look good, but it doesn't necessarily have to look like a box on the outside. Here's a building, a multifamily building with two different units highlighted in orange. You've got this looks like a two-bedroom unit, and you've got this one-bedroom unit down below. In the one-bedroom unit down below, we've got basically 4 corners to this box that we created. And we have 18 corners in the unit up above. So again, every single one of those corners is an opportunity for air leakage, any connection. So it's going to be a heck of a lot easier to air seal this simple shaped box on the bottom there. Know your priorities. Okay, so talking about bubbles again. On the left, the orange is highlighting the exterior envelope of the building. That is our primary responsibility, is to make sure the overall bubble is nice and tight and insulated correctly. And then once we're confident that we've got that done, then on the right here, we start focusing on each bubble inside that big bubble. So keep that in mind. This is a lot to chew, and so don't try to chew it all at once. Make sure you take step one first, get your exterior envelope figured out, and then focus on each apartment. Seal at the perimeter. So this is our preferred way of doing compartmentalization. It's not always implemented. In fact, it's rarely implemented, depending on what you're doing. If you can seal the connection of every wall to another wall, so we've got interior partition to demising, we've got interior partition to corridor and to exterior, we've got exterior and demising. Basically, every time, if you look at the diagram on the right here, every time you have an assembly that's connected to another assembly, even if there's no obvious big gaps, air is going to leak from one assembly to the next unless you do something to stop it. Believe it or not, air is going to leak between this stud and the back sheet of the drywall, or back of the sheet of drywall, which is why in this detail we're showing the sheet of drywall on the primary assembly, whether that's exterior or corridor or whatever, that runs past the interior partition down here. And basically what that does is that stops any air that's in this exterior corridor assembly from leaking into this interior partition, which will eventually leak into the apartment. And seal drywall enclosure. So if we go back a couple of slides. So we talk about our bubbles. On the left-hand side here, this is our exterior envelope. That's kind of a no-brainer. I think people are pretty good about getting up to speed on that. Our primary air barrier is the exterior, sheathing, insulation, whatever. When you get down to unit air sealing, you're looking at all these possible ways for air to leak into the unit through the drywall. So up here we've got plumbing penetrations, electrical boxes, our P-tacks. We hate the P-tacks. I mean, we don't hate them, but they're hard to seal. Even the connection between your door trim and your drywall. In theory, where they cut the drywall around this door, that is a place where air is going to be able to sneak in some way, somehow. So, most scopes of work are going to include caulking the millwork to the drywall, and so that usually takes care of the problem. But if you don't do it, you're going to have leaks there. Okay, so here's where it all starts. You've got to get this stuff into the design. Choose the details and specifications specific to each project. You're welcome to, I've got a link to these are just images from our air sealing guide that we distribute freely. You're welcome to cut and paste those and put them in your drawings and specs. However, that's not nearly as effective as customizing your own details and your specifications based on your specific project. Because you don't have to do everything. You only have to do enough things to get you to a certain level that you're being tested to. Here's something that is easy to put in. It might catch some contractors off guard. You've got to require unit-by-unit testing, not guarded testing or whole building testing. We're going to talk about guarded testing later, so sit on that one for a minute. If you don't have a specific air leakage requirement that you have to hit, like in a big multifamily building, it's technically commercial, and so you can get away with just inspecting that enclosure, at least at this point. However, for a best practices measure, we suggest putting the 0.30 CFM per square foot of enclosure in there, even if you're not doing any of these other programs that we talked about earlier. And be specific. Our rule of thumb for gaps smaller than 1/4 of an inch is to use caulk. Anything greater than 1/4 of an inch, use foam. The thing here is that caulk typically shrinks and cracks when you put it on too thick. Use your appropriate sealants. A good example here is the low expanding foam around your windows. If you use regular foam, sometimes it can expand too much and mess up the movement of the window. This never gets done. Clean out cracks before applying sealant. Otherwise, you're just sealing to the dust, and sometimes it works. A lot of times it doesn't. So instead of just having the contractor kick at the crack with their boot and then caulk it kind of poorly. It's better to have it all cleaned out so it seals nice and tight. You know, something we get asked a bunch but haven't ever done research on is, well, how do you know if you've met your infiltration targets now, how does the building perform in 5 years, 10 years, 15 years? I don't know. That's a good question, and we'd like to research that at some point. Consider new products. One of them out there is elastomeric sealant. I won't mention the actual manufacturer, but there are new ways out there to stop air leakage, so look into it. I'm sorry, new materials. All right, design exercise. I basically have 3 examples here of projects of mine, different assembly types, different programs and different approaches. I'm just going to flip through these examples kind of quickly. If we've got time at the end, we can come back to them. This is mostly just to shine a light on how we go about this process and what works in some instances and what doesn't. So example 1 is a block and plank building with some steel framed walls too. As far as our compartment goes, I'm going to try to make a square here. See if this shows up for you guys. Oh, maybe you see that. There's a blue square. That's our enclosure of this very simple shaped apartment. Exterior walls are steel, steel studs that rest on the plank. Exterior envelope does a good job of sealing those because there's a liquid applied air and water barrier. Let me try my arrow again out here. At this point, the exterior envelope, since this is our priority, our biggest concern is window 1, window 2. Those actually are pretty easy to seal with our low expanding foam like I talked about before. When you start getting to the mising walls, these are block walls at this point. They're sealed to the plank below and the plank above with grout. You know, they're fully grouted. That typically works pretty well in stopping air leakage. Very rarely do you have penetrations through these demising walls. So again, there's not a whole lot to seal there. Same thing for the corridor wall. Again, these are block. If everything's grouted and mortared nice and tight, you really don't have a whole lot of opportunity for air leakage there until you start talking about in this corridor walls where we're going to have some plumbing penetrations and whatnot. Really, the only thing here to hit is the entry door, again, which is grouted solid. So in plan, in 2 dimensions, this isn't too tough to seal. This is a highlighted, I'm highlighting that connection between the block walls and a steel frame wall or an interior partition. This isn't the greatest example to use, but in this particular building, let me go back a slide. This connection right there, where the block demising wall met the exterior steel wall, we had suggestions that were very comparable to this detail here as far as making sure they're sealed tight to each other so there's no bypass at this connection. Unfortunately, in this case, they did not follow our advice, and in the units that had this particular assembly connection, we failed at the first round, and they said, well, what's happening? And we said, well, you remember a year ago when we talked about how you seal this, you guys didn't do it, and now we're failing. So just to highlight here, you're taking the interior partition and you're making it intersect that block wall, and then you're sealing it right there. So it's basically disconnecting these 2 assemblies to stop air from transferring around. So as I mentioned quickly before, that was a nice 2D diagram that we started with this unit, but it's very, 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 very important. You've got to look at these units in 3 dimensions. So what we're seeing here is a wall section. You've got a plank above, plank below. Those really don't leak a whole lot. All of the penetrations are typically filled. So again, what we're talking about is these connections between the steel frame wall and the planks and the wall above. Whatever you can do to seal that connection, similar to, trying to back up, similar to this detail here, depending on your exact situation, you got to stop your air leakage there. So as far as penetrations go, again, we've got these nasty P-tacks. I won't get into the details of those. And one more penetration you've got is the shared exhaust for this unit. You've got your intakes in your bathroom, the kitchen, you got your fan here. really all we're worried about is where that thing pokes through the wall. So make sure that gets sealed. P-tacks. So first step is to seal the sleeve to the rough opening. That's pretty easy. You do it mostly like a window. The second part, which is actually not shown in this diagram here, is when they slide that P-tack in there, they've got to get it slid in so that the P-tack fits tight against the sleeve. Oftentimes it doesn't happen. Nothing is square in the real world, and we end up foaming. Instead of sealing the sleeve to the drywall here, which is important but not as important as this dotted line here, is where the P-tack gets sealed to the sleeve itself. Again, every situation is going to be different, but just be cognizant of the P-tack trickiness. In this case, they sealed the penetrations under the sink. They sealed the hot water penetrations. They sealed the vent takeoffs. And in this case, we hit 0.3 OCF and 50 per square foot of enclosure pretty easily, not counting that steel to block connection that they screwed up. Okay, so example 2 is a wood frame building. Where is this one? This one's in New Jersey, actually. The previous one was in Yonkers. Again, as far as priority goes, we want to focus on the exterior wall. They used an exterior liquid applied membrane, which again is pretty effective at stopping leaks in the connections in the in the sheathing in this building. You can't always do that based on weather considerations. Sometimes people think Tyvek is a chic air and water barrier that is just tacked on the building. They think that's an effective air barrier. Unless you do a really, 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 really good job of it, you're not going to get the performance out of it than you would out of a liquid applied air and water barrier, or rolled on, sometimes they call it, or even a peel and stick. That's even better. That's the creme de la creme as far as we're concerned. So we're worried about our window penetrations on the exterior wall. Pretty easy peasy. Let me skip ahead here. There's better details later on. So to look in 3 dimensions again in section, we wanted to make sure that this exterior wall was sealed to the plate. And we're doing this in 2 ways. We're sealing the plate to the slab, and that'll stop any air leakage from sneaking under the plate. And we're also sealing the second little dot there, maybe you can just barely see it. That's sealing the drywall to the wood plate itself. So this is kind of a double connection at the bottom of the wall, which will keep air from outside from leaking under the plate here, and it'll also keep air that may have leaked into the wall cavity from leaking into the apartment there. Here's the top of the wall. It's a flat roof. They're showing a caulk joint right there, which really isn't feasible because there's no way to get to this after it's framed. So where that actually happened is right here. Basically, it's connecting the roof to the wall, making sure that there's no air leakage at the top of the building. So we've got the bottom of the building, the top of the building. Now here in the middle of the building, here's our duct penetration to the exterior wall. You've got caulk at that penetration on the outside, or sealant, and then we also have it on the inside, belt and suspenders, because the outside is going to be fighting the weather, from here until whenever the building's demolished. So we want belt and suspenders at this case. Again, we're seeing caulk here at the exterior wall plate, and at this point, if we've got the exterior air and water barrier nice and sealed, we're really not so worried at this point, but we are at this point right here. Again, we don't want any air that's inside the exterior wall to leak into the apartment. Same thing down here. We don't want any air leaking from the floor cavity into this exterior wall assembly. Typically, I'd actually want to see another caulk joint right there. Separate those cavities. Put up as many roadblocks as you can between one cavity and another. So in plan here, let's skip one. Here we go. Connections of the walls. Again, we're sealing the drywall to the wood in this example before the second piece of drywall goes in, or do one or the other. Long story short, you don't want any air to sneak from this cavity into this cavity. This squiggly line here is meant to represent, a wire, for example. You want to make sure you seal that wire penetration through that last stud too. Now we've got 2 separate cavities, and you're going to be minimizing air leakage that way. It gets a little bit trickier at a double frame demising wall, a double stud wall, but basically the same rules apply. Seal your drywall to your framing, and then any connections through your framing or penetrations begin separating those cavities. This is the example I showed before. This requires extra coordination. If you can frame the walls with a little gap between them so they can run this drywall past, then that's going to save you all of this extra work from these details. But like I said, it's hard to get contractors to actually enact this detail here. And sometimes it is required, like for steel framing, that's actually very common. With wood framing, not so much. This is a cross-section of a double demising wall at the floor assembly between the second and third floor. A lot of caulking is happening here, and again, it's happening between drywall and the framing. We're trying to separate this assembly down here from this double frame assembly up here, and hopefully that stops air from leaking into the unit there. You can see in this case, they took the drywall and the demising wall all the way to the underside of the subfloor, and they sealed it right there. That's going to be pretty effective in keeping the air from this floor cavity and this floor cavity from leaking into this wall here. Roadblocks. Put up as many roadblocks as you can. As far as penetrations go, this is our bath fan, and our dryer vent, I think. Here's our kitchen vent over here. So it's pretty easy to seal. This is showing our duct layout. So these are all the registers. Here's your trunk. So if your ducts are not located in the unit below the drywall that is the top of your apartment enclosure, any leakage in your ductwork will contribute to leakage in your apartment. So sometimes ducts are considered to be totally separate, but really when you think about it, they are an extension of this bubble that we're creating around each apartment. Just like your single-family house when you have ducts up in the attic. Same deal. Although I will say in this case, the energy loss is much less here because you've got a unit above you that's at the same temperature as your unit. So the energy loss is not bad, but you still have the air loss. Okay, so to go back to these are excerpts from our air sealing guide. We had to seal all these penetrations, connections. You know, there's duct boot, recessed ceiling fixtures, access panels. All these are opportunities for air to leak in the apartment. And this down here with the electrical box, what we highly suggest is sealing the box first, and then you seal the box to the drywall once the drywall goes on. As an option, you can use these gaskets behind the cover plates. They don't work nearly as well. So we usually let this up to the contractor. Whatever you guys want to pay for, go for it. But we're going to warn you that these gaskets, they work sometimes, they don't always work. Okay, in section, again, we're talking about our connections at floor to wall, our window rough opening. We've got connections here at interior partitions to this floor cavity, and again at our demising wall and the floor cavity there. Put up roadblocks. Try to stop air in as many places as you can. Okay, question and answer. How do you want to do this, Brett? We've got some comments. What do you want to do?
Saying, I got one comment here, and if anybody wants to drop in some more, we can quick answer them. But why not whole building testing? It seems that would be preferable, but perhaps more difficult to do.
Yes. The bigger the building, the harder it is to do. It can be done, and we do it. It's just a matter of what you're trying to meet, whether it's co-compliance or one of the programs. Whatever's required. Usually they're very specific about whether you do unit by unit or whole building. Mostly we do unit by unit just because that's what our programs require that we're certifying under. And I'll talk about later why I've got a slide later on about what the benefits are to doing unit by unit versus whole building testing.
Great. Well, I don't see anything else right now, so maybe we'll just. Oh, here we go. What's your opinion on sealing plumbing chases at each floor to reduce stack effect?
It's not often done. It's a good idea. It's not often done. I would say the easiest way to address that is to seal the bottom of the chase, seal the top of the chase, and be confident that that is knocking down the stack effect. You could try to do it floor by floor, but it's not common in my experience.
So here's a good question, and I think plays right into especially what we're talking about with lead verification, lead for homes verification. Do you typically see the rater, energy inspector, providing oversight during the construction, maybe during the pre-drywall to ensure this is done correctly? Or what other challenges exist on verifying this is done right before everything's done?
Yeah, that is a good question. Well, for any project where you need a third-party verifier, so, lead, Energy Star, et cetera, you've got someone like me who's in there with a set of eyes, an independent set of eyes that's specifically looking for these things. I typically find that our contractor and architect clients rely on us to do that because then it saves them the time of having to check themselves. That said, the responsibility, in my opinion, is firmly on the contractor because, in theory, you should be having these air sealing standards and details in the contract documents, in your drawings and specs, and it's up to the contractor to live up to those. Assuming, you need to give them as much help as they can, but it's ultimately on their responsibility, or it's their responsibility. So we highly recommend, even if we have clients that are building something and they're not going through any of these certifications, we will come in and do third-party inspections for them just because they found that's the most effective way to make sure what they want done actually gets done. But it depends. Every project is different. Sometimes the architect takes charge. Sometimes the contractor takes charge. Sometimes it's a third-party code inspector like in New York City with TRE. So,
Great.
there are a lot more comments now.
Yeah, so when more projects have demising drywall and at the ceiling rather than go all the way up to the underside of the deck, has this been a recipe for success or disaster in NYC?
It all depends. If you, basically by taking the demising drywall all the way up to the floor above, the underside of the deck, you have effectively taken that cavity between the deck and the ceiling below from being, several square feet or several cubic feet of volume, and you've broken it up into one smaller chunk per apartment. So basically you're making a big bubble into a smaller bubble, and that always helps reduce air leakage. However, you definitely have opportunities farther down the line, like we were talking about in the drywall penetrations, to slow down your air leakage. So yeah, we definitely suggest connecting that demising wall and the underside of the deck, but we've seen success by not doing that, but you have to try harder elsewhere.
Great. Creating a slight positive pressure in each apartment can help air infiltration, but can cause issues in the corridors and et cetera. Any suggestions on how to deal with this?
A slight pressure is not going to help infiltration. In fact, it'll do just the opposite. It'll exacerbate exfiltration, which can be just as bad. What we suggest is having all volumes balanced and as neutral as possible. So to go back to that diagram earlier on where I had the little pink bubbles in the multifamily building with the arrows, anytime you have a pressure difference, you're going to have air movement. So we try to minimize that as much as possible. I don't want to get into the details about code and being able to supply outdoor air to the corridors and have that leak into the apartments and vice versa. That's sort of a rabbit hole that I don't want to get to today, if that's all right. It's a good question, but we could spend hours on it.
Yeah, no, fair enough. What about leakage from the door, not the door frame, to the common corridor?
Great, another good question, and it actually sort of dovetails into the last one. Sometimes we see that apartment entry doors from the corridor have to be gasketed and weather stripped. Gasketed and sweeped. Other times not. We typically put our blower door in the apartment entry door, and we make sure the corridor pressure is equivalent to outdoor pressure. Basically, we're opening up windows and doors in the corridor to make it seem like we're blowing it outside. So in that case, really, you're not even testing the tightness of the door because that's where the blower door equipment is going. Again, this is sort of a black hole of considerations. So It's a good question and something to be cognizant of. And our opinion is that you want to make sure that apartment door is tight because it controls sound and odors and all kinds of nasty stuff that could potentially be coming from the corridor. That's my personal guidance.
Do you find it's better just to recommend people just overall avoid can lighting to avoid air loss to them, which is notorious, or do you not really see that as an issue?
It all depends. If you get an airtight box and make sure it's sealed tight to the drywall, you can get them tight. I will say the coolest thing I've seen lately is these LED fixtures that look like recessed lights, but they actually fit inside a regular rectangular box. So they look like a recessed light, but you're just putting up a regular rough-end box. And you can seal your rough-end box super easy, and then these LEDs sit up there, and they're efficient, and they look good. Yeah, they're pretty awesome. So I'd suggest going that direction.
Do you get locked into replacing it with their product, though? That might be expensive, or?
Yeah, but you know what? I mean, we're seeing LEDs just, really take over as far as lighting goes. So,
sure.
And they last forever, not forever, but a long time. So I really wouldn't worry about that personally.
Yeah, oh yeah, LEDs are great, yeah. All right, last question before we move on here. Some of the details indicate sealant inside the stud cavity on both sides of the sill plate. How do you install the sealant on the interior close-up side of the wall prior to hanging the drywall and ensure you have a good seal when you attach it?
Yeah, it's all about sequencing. So anything that the detail you're referring to can be applied. Let's go back real quick. Yeah, so you probably are talking about this one right there. That's actually just a bad detail. You can ignore that. What we're really worried about is this one down below, where typically the drywall is kept up off the subfloor by at least half an inch, even more sometimes. And so that's where you would be able to access a connection between the drywall and the base plate. And then, let's see, yeah. We can flip back to a different one. This connection right there you can definitely get to, after the wall is sheathed, but before drywall goes on. And then these you put on after drywall goes on because they're held up from the floor. It's held up from the floor. Okay?
Yeah, great. Let's move forward.
Okay. All right. Got about 6 minutes left. Okay. I think we can do this. How do we evaluate air sealing during construction? Okay, we kind of had a question on this. The way we do it is step one at pre-drywall. That's when we're looking at that big exterior bubble at the envelope of the building. And this is mostly visual inspection. Sometimes you can use diagnostic tools like IR cameras and whatnot, but you really shouldn't have to. Second step is at final completion, and that's when you use the blower door. So step one, visual inspection. Step two, using your testing equipment. Visual inspection, here's a picture of what I see typically when I'm doing this inspection. And all these little orange arrows indicate potential areas for leakage. So the key here is to not get overwhelmed. Know what you're looking for, know what you're expecting, and just be methodical about looking at each item. Use a checklist. Use paperwork. Don't try to remember all this stuff from memory, which I do, and I find myself doing it, and my eyes are crossed after spending 2 hours on site, and I can't remember anything. So use your paperwork, use your checklist, whatever is pertinent to the program you're doing. So over here on the left side is the Lead for Homes Thermal Enclosure Inspection Checklist. That's the old version, not the V4 version. On the right here is Table 40242 from the 2009 International Energy Code. I mean, all this stuff technically has to be done as far as the Residential Energy Code is concerned. So just use that as your checklist. The blower door, this is a manometer. I won't go into it, but more importantly, guarded versus unguarded. We said we'd talk about this earlier. In the middle here is the apartment that we're actually testing, and there's my little red box that indicates my blower door. These arrows indicate the negative pressure that blower door is going to apply to the entire enclosure of this apartment. So if you were to do guarded testing, what guarded means is that you're putting a blower door above, to the left, down below, to the right, and you're basically neutralizing the pressure between the unit you're testing and the units around it. So they're all at negative 50, and in theory, you don't get any air leakage at those enclosure assemblies. However, it doesn't always work, because as we all know, buildings are not very simple square boxes like I've drawn here. So what you get with guarded testing, with all these blower doors, you are accentuating you're basically knowing exactly how much air is coming from the exterior versus other apartments. We don't care about the air that comes from other apartments because there's no energy loss there, because they're all heated too. However, with unguarded testing, you're also able to verify that you're not going to have any moisture transmission or fire smoke transmission from unit to unit, no comfort issues, noise, smells. All these things you're able to verify through unguarded testing, through compartmentalization. That's why LEED for homes mid-rise, for example, requires you to test the enclosure, is because we care about these things, not just energy at the external envelope. Communicate your findings. Now, again, if you don't have someone like me doing your third-party inspections, just be clear in your communication to the team what you saw and what you expected to see, and where it came out. So tell them what your compliance standard is. Tell them what your targets are. Tell them what you got. Tell them if they passed or not. Sometimes it's not really apparent. They ask, well, did we pass or not? So, and then if they didn't pass, tell them how to fix it. Corrective measures. Okay, this is on the left, just a regular picture. On the right is an infrared picture showing air leakage coming in at what I assume is the vent for this microwave. Air sneaking in and it's leaking into the apartment. Long story short, if you see me on site with an infrared camera, that means you probably screwed up. There's no reason for me in a new construction or even a gut rehab building to bring in an infrared camera, because we should have taken care of all this stuff at the stages when it should have been taken care of. If you see me with an infrared camera, that means somebody dropped the ball, and we want to avoid that. Air sealing for non-architects. You look at the body language here. Arms crossed. This guy's sort of trying to be helpful, but still has his arms crossed. This guy doesn't want any involvement whatsoever. He's got his hands in his pocket. This guy's running out the door. You got to choose someone to be responsible for air sealing. Otherwise, it's never going to get done, and everybody's going to point fingers at everyone else. So as an architect, that's hard to do. If there are any contractors, GCs, project managers on the call, yeah, that's up to you. Say, look, this trade is responsible for following up after all the other trades when they, don't seal their pipe penetrations and their electrical penetrations and whatnot. So put one person in charge. So in summary, you got to understand why, how, and where this air leak is happening. Know the target that you have to hit. Get your details in the drawings. Get them in the contract document so that when, again, it's going to cost you $50,000 extra at the end of the project to do all this extra air sealing work because you failed your blower door test, you can say, look, we had it in our drawings and our specs, and it's not our fault that we didn't get there. The responsibility at that point is on the contractor. Inspect and test. You'll have no idea what you've got for air leakage until you actually test it. Communicate your findings. Try not to make this some enigma to the project team. It's not rocket science. We just need to get it into everyone's lexicons as something that they're comfortable doing. And then at that point, you should succeed. We've got some resources. Feel free to follow these links. This one right here is our air sealing guide. Gosh, that's from Greenville last year. Download it. Use it. We don't care. Get it out there. Spread the word. The Building America Solutions Center is awesome. If you haven't checked that out, get in there and look at those details. I don't know, here's a paper we wrote if you're really looking to, get to sleep, you need something to knock you out. You can read this carb study that we did. And then here's just sort of a nice air leakage guide from the Department of Energy. Nice diagrams and stuff. Okay, that's it for me. Is there any questions?
Yeah, great, everybody. We got a little bit of time here, so please drop your questions in. For those of you listening live here, right after we wrap up, you should get an email that has a little quiz, a little survey. Please take that survey whether you're continuing it or not, and the email should contain your certificate as well. For those of you listening on demand, that is the recorded version, so I'm not talking to any of you here right now live. Please take the 10-question quiz to pass and get your certificate from there. So let's see what questions are coming in when we wrap up. So we will have a little handout of the slides here, as well as the air sealing guide and this recording of this event on our website as well. And so you can watch back through that, and you can listen to the Q&A if you want to hear some of that. So that's an answer to that question. On a wall with 2 layers of drywall, do you like to see interior layer sealed or the exterior layer sealed, Steve?
Good question. I would say interior because you're sealing the drywall to the framing typically, or just the slab or whatever. It's going to be a lot easier to get to it at the first level. In theory, if you're using a product like expanding foam, you could do it at the second level, but I think that's going to be a little riskier. And in case anybody wonders, I get this a lot in the field. I get someone saying, well, we've got 2 layers of drywall and everything, and I say, well, that's nice, but as long as you aren't sealing the actual connections of either layer, you could have 10 layers of drywall. It's not going to make a difference. The leakage happens at the connections, not actually at the layers of drywall itself.
It does seem like we're moving from communicating this kind of stuff in air changes per hour ACH to now CFM per square foot. What I guess what's the broad difference between the two?
Okay, so depending on the size and shape of the dwelling, apartment, unit, whatever you want to call it, your CFM 50 standard is going to be slightly easier to hit than your ACH 50 standard. It's rooted in the fact that ACH 50 typically applies to a building that's primarily exposed to ambient conditions, whereas the CFM 50 metric's going to apply to a unit that's got surfaces that are shared with other units. The other thing is that, when you have an apartment that's funny shaped or whatever, you get penalized. The air leakage doesn't happen through a volume, it happens through a surface area, right? Our enclosure is actually a surface area, it's not a volume, and so, you can easily get penalized unreasonably if you're testing based on volume and you've got a funky shaped unit with lots of exterior or enclosure area. It's not a great answer, sorry, it's not very clear, but mostly the ACH is referred to for units that are primarily exposed to ambient conditions.
Great. Do you have a preferred method to seal heat and AC ducts?
This is a tricky one. The most effective way I've seen it done is mastic tape. And this is not to be confused with foil tape. It looks like foil tape, but instead of having the acrylic, the clear sort of stickiness on the back, it's got a layer of mastic. It's thicker, it's heavier, it's a thick gray, sticky material on the back side of the foil, and that actually will hold up a lot longer than the foil tape with just the clear sticky stuff on the back. The reason I say that is because you can typically get a nice connection between the metal duct and the surface of the drywall. You're wrapping the entire opening of the duct penetration through the drywall. Sometimes we'll see the connection caulked. The problem is that caulk has a hard time sticking to the actual cut edge of the drywall, the gypsum itself. It's not going to stick to that nearly as well as it would stick to the paper on the drywall. It can be done. You just have to try a little harder to do it. The thing is, the mastic tape is a little bit more expensive, but again, it's way, way, way more effective.
Great. And I don't know if you know too much about hot, humid climates, but a question in those areas, would be, would you put an air barrier above or below a plywood subfloor over a vented crawl space?
I'm going to stay away from that one with a 10-foot pole. It
Okay.
all depends on where you are, what your crawl space details are, what your air barrier details are. Yeah, it can be pretty complicated. So that's one that should be definitely answered on a specific basis, project by project.
Great. Well, to wrap up, Lead for Homes version 4 is coming out here pretty quick. Air sealing and compartmentalization on multifamily and mid-rise projects. They're going to be really cracking down on that. What is just overall? What are your thoughts on how do you think that's going to be achieved, and any just broad level advice on how to do it?
The biggest 10,000 foot view here is to just be aware of it and tackle it just like any other requirement, whether it's fire code, mechanical code, plumbing, structural. It's just one more piece of the puzzle. And as long as you take it seriously and you convince your construction team to take it seriously, that's number one. Number two, I would say, is when possible, work with people who have successful experience meeting these requirements. I've found that we can do one new project with a builder we haven't worked with before, and I guarantee the second project we do with that builder is going to be a lot smoother than the first one. So basically, get your feet wet, and more importantly, make sure you work with people who also have their feet good and wet. Yeah, and then the third thing I'd say is just don't be afraid to ask. Get a third-party consultants involved like us, or, just we have success. We certified thousands of units, so don't be afraid to reach out, and we can help you through it.
All right, great. Well, Steve, I really appreciate your time here. Thanks for everyone for joining us today at our free webinar Wednesday series. Make sure to stick around. Come back, join us next week for the continuing series. Steve, where can folks learn more about Stephen Winter Associates?
Swinter.com.
Swinter.com.
SWINTER.com. Yep.
Perfect. Yeah. Check it out, everyone. Thanks for your time. Enjoy the rest of your week.